Hi viewers, today we will solve a delta Y conversion circuit from the Boylestad book. So this is example 8.27 from Boylestad. 8.27 from Boylestad. Let us draw the circuit given in the book. This is terminal B, this is A and this is C. This is the resistance RC, which is 10 ohm, and this is RA, and this is 30 ohm, and this is RB, and this is 20 ohm. Now the delta circuit is given. We have to find out the equivalent Y circuit. For finding out this equivalent Y circuit, we will proceed step by step. Let us draw the circuit again for convenience. So this is terminal B, terminal A, and this is C. And this is RB, which is equal to 20 ohm. And this is RA, 30 ohm. This is RC, 10 ohm. Now the equivalent Y resistance or equivalent Y circuit for this delta will look like the equivalent Y circuit will look like this one. So this is simply from the delta Y conversion circuit. So which you can remember that, say, for this delta, what will be the Y? Y will be just simply like this. So we have brought this Y circuit here. Now let us denote this Y circuit resistance as R1, this one as R2, this one as R3. Now we have to find out the resistances R1, R2 and R3. Now the value of R1 will be, in the numerator it will be the two side resistances of R1, that is, two side resistances of R1 are RB and RC. So the multiplication of RB and RC divided by the numerator, which is the summation of all the three delta resistance, that means RA, RB and RC. So RA plus RB plus RC. Now if we put the values, RB is 10 ohm multiplied by 20 ohm, where RB is 20 ohm and RC is 10 ohm, and divided by the 10 ohm plus 20 ohm plus 30 ohm. So this is equal to 3.33 ohm. Now similarly, let us find out the R2. So what will be the value of R2? R2 will be, for R2, the numerator will be the two side resistances of R2, which are two side resistances of R2 are RC and RA. So this is RC multiplied by RA divided by the denominator remains same, which is the summation of all three resistance. So RA plus RB plus RC. If we put the values RC and RA, then it will be 10 ohm multiplied by 30 divided by 10 plus 20 plus 30. So we find out this is a 5 ohm. Now we find out the R3. So similar to R1 and R2, for R3, for this R3, the two side resistances are RB and RA. So in the numerator it will be multiplication of RA and RB divided by RA plus RB plus RC. So For all the three resistances, the denominator remains same, Ra plus Rb plus Rc. That means all the summation of all the delta resistances. So if we put the values, then Ra and Rb, 20 multiplied by 30 divided by 10 plus 20 plus 30, so is equal to 10 ohm. Now if we draw the equivalent Y circuit, removing this existing delta, then the Y circuit will look like so. This is terminal A, this is terminal B, this is terminal C. We have denoted with terminal A, the resistance will be R1. So this is R1 with a value of 3.33 ohm. So this is 3.33 ohm. And for with terminal B, we have denoted it as R2. So this is R2. The value of R2 will be 5 ohm. So it is 5 ohm. And with terminal C, it is R3. So R3, it will be equal to 10 ohm. So this is the equivalent Y circuit of this equivalent delta circuit. Thank you for watching.